Hey, what's up? In this video, we're going to be going over tangent and secant lines using derivatives. Yeah, so we're just going to be going over it. Hope you like it. Hope it helps you some. If there's any questions or concerns about anything, please comment them in the comments below. Okay, so let's start off with derivatives. I'm going to assume you know what a derivative is, and if you don't, I'll make another video about it. Let's say we're taking the derivative of some function, e times e to the x. Okay, so let's say we want to graph this, and crap, what does it look like? It looks something like that. The function looks something like that. This is the y-axis, x-axis. All right, now let's say we want to find the slope, the tangent line of this function at some point. So let's say just right here, and then on the x-axis we can call that point x1, x subscript 1. So for a tangent line, what would the tangent line look like? That would just be a straight line that only intercepts at that one point, and it just goes off forever as a linear function in that same way. Crap, am I out of focus? Oh, I'm sorry. Okay, wait. Okay, so we want to find the slope of this tangent line. So at x equals 1, so we would add in right here d of x1 over dx is the derivative of x times e to the x. So what we do is, we use the product rule, find the derivative of this, and then it would just be e times e to the x plus e to the x. And then what do? We find the limit as x approaches x1. So whatever point we're finding the slope of this, and then we would just have e subscript 1 times e to the x subscript 1 plus e to the x subscript 1. And then this would be whatever slope it is. So let's say x subscript 1 was like 2 or something. Then that would be 2e squared plus e squared, which equals 3e squared. So that's the slope of the line. That's the slope of the tangent line of this function when x equals 1 or x equals 2. Isn't that a beautiful thing? How this all works? It's a beautiful thing. It's a beautiful thing. So just take a moment to acknowledge that, and then we'll do another problem based on what a tangent line. Okay, so let's make another function and find the tangent line of it. So this is the slope of the tangent line when x equals 2 of this function square root of the product of 1 and negative x squared. Okay, my bad. I just keep on thinking I'm out of focus. But just take a moment to acknowledge this problem, and then we'll try to solve it. Alright, so let's graph this, just as a quick little graph. You may notice this is the equation for a semicircle with radius 1. So this is 1, and this is negative 1. They both intercept at 1 and negative 1. Because if you plug 1 into this, it equals 0. Plug negative 1 into this, it equals 0. So the question is, if the only real values for this function are between 1 and negative 1, how could you find the slope of the line at 2? Well, then you get into maybe like complex analysis, and then you take the imaginary plane, because there's an imaginary plane. I hope you know what imaginary numbers are. I can make a video about it if you don't. So, what would the slope of this line be on the imaginary plane? That's pretty much what we're asking. So, what we do, find the derivative of this using the chain rule, whatever. And then it's negative x times, it's just trivial steps. So then, let's say the limit as x approaches 2 of this function. Plug 2 in, and then it's negative 2 times square root of 1 over 2 squared, which is 4. So then we have, that equals negative 2 over I square root of 3. But then the I and the negative cancel out, so then we have 2I over negative 3, and that is the slope. So, yeah, that's pretty much what's up with tangent lines. Use a little imaginary numbers in there. Hope it didn't bother you too much. I don't really care if it did. You know, use your brain a little bit. So now we're going to be going over secant lines. And secant lines are a beautiful thing also. They're similar to tangent lines, but they're not exactly like tangent lines. So, let's say we want to find the derivative of, I don't know what function, just square root of x. Yeah, square root of x. And then let's graph it. So here's the y-axis, the x-axis. And then it looks something like that, square root of x. Alright. So let's say we want to find the slope of a line that intercepts at 2 points on the graph. So something maybe like, you know, it intercepts at these 2 points. Now let's call them x2 and x1. So you could, the way we find this derivative is take the derivative of x squared, whatever the function may be. We're just using x squared as an example. But then we take the limit as x approaches x2 minus the limit as x approaches x1. This is assuming that x1 is a smaller value than x2 of the derivative of that same function. Oh crap, wait. Of that same function, x squared. So, what the steps for finding the derivative of the square root of x is trivial. So, it's just 1 over 2 square root of x. And then let's just plug x2 into that. Wait, can you see this? Okay. And then we have 1 over 2 times the square root of x2. And then we can do the same for this, and then we'll get 1 over 2 square root of 1 subscript 1. And then that's whatever the slope of this secant line is. And it changes depending on what x1 and x2 are, but you get the idea. Like, we could say x1 is equal to 1, let's just say it's 1, and then x2 is equal to 4, and then we plug that in, and it's 1 over 4 minus 1 over... Yeah, and we get the slope. Of course, this is drawing it out way harder than it has to be, but it's important that you get the fundamentals before you're able to just, do it all willy-nilly and whatnot. So, it's another good example we could do. Good. Well, I think that's a good note to end this video. If you understand the concepts, and if you don't, please comment, talk about what you don't understand. We can make another video about it. Okay, so I'm just gonna leave with a little practice problem. So, take this function, find the tangent line at x equals 10. Alright, hope you like this video. Bye.